Hello dear student. So today I welcome you all in this session. Here in this session we will be discussing lecture number 7 of carbon and its compound. So let's move on to the next slide. Okay students, so here we will be talking about the chemical properties of carbon compounds. Okay, so carbon compound shows combustion. Okay, now carbon in all its allotropic forms burns in oxygen to give carbon dioxide along with the release of heat and light. So when you burn carbon or it allotrop, I think you might be familiar with allotropes of carbon. We have discussed very deeply what are the allotropes of carbon, graphite, okay, and then diamond, okay, and then coal. So these are basically the allotropes of carbon. So when you burn these carbon allotropes or carbon in the presence of oxygen, so what will happen? They will produce carbon dioxide. Okay, they will produce what? Carbon dioxide. So most carbon compounds also release a large amount of heat and light on burning, and this will also produce a large amount of heat and also light. So this is the chemical property of carbon and the, you can say, its allotropic forms. Okay guys, I hope this is clear to you. So now let's talk about these equation. So in first equation you can say that carbon is reacting with oxygen and it is producing carbon dioxide, and in this reaction heat and light is also produced. Now let's talk about the second reaction. So here you can say that this is what? This is methane. So this methane is reacting with oxygen and it is forming carbon dioxide plus water, and heat and light is very necessary. So heat and light is also produced. Okay guys, I hope this thing is clear to you. So this reaction is not balanced. So if I want to balance this reaction, then what will I have to do? I will have to check that which element is not balanced. So you can see that hydrogen, here on the left side hydrogen is 4 and on the right side it is only 2. So I will multiply here with 2. So now hydrogen become balanced. You can see here hydrogen is 4 and on right side also the number of hydrogen is 4. But oxygen is not balanced yet. So we will start balancing oxygen. You can see on the right side there are 4 atom of oxygen is present, and here only 2 atom is present on the left side. So if I multiply here with 2, so now you can see that this equation is balanced because all the elements are balanced. You can see carbon here is 1 and here also carbon is 1, hydrogen here is 4 and here also hydrogen is 4, and you can also see that oxygen here is 4 and here also 2 plus 2 oxygen is 4. So I hope guys this equation is balanced. Now let's talk about this equation. Equation number third reaction. Basically this is the reaction between ethanol and oxygen. Okay, this is what? C2H5OH. This is ethanol. This is the formula for ethanol. So when this is reacting with oxygen, so this will form carbon dioxide. As I told you that all the carbon and its allotrope will form carbon dioxide, and in this case water will also be produced, and heat and light is also produced. So as you can see this equation is not also balanced, so we will start balancing it. So as you can see the number of carbons is not balanced here. So what we will do basically, First of all, we will also check other elements. So hydrogen is also not balanced. Here only 2 hydrogen is present, and here 6 hydrogens are present, and here oxygen is also not balanced. Okay, so if I multiply here with 2 and if I multiply here with 4, okay, so now you can see the number of carbon is balanced. Okay, because here 4 carbon, basically the number of carbon is balanced. Here 4 carbon is present, here also 4 carbon is present. Okay, now what we can do, we will basically multiply here with 6. So now you can see the number of hydrogen is balanced. Here 12 hydrogen is present, and here also you can see that 5 plus 1 6 multiply with 2, 12 hydrogen is also on the left side and 12 hydrogen also on the right side. So hydrogen is balanced. Now what we will do, basically to balance the number of oxygen, I will multiply here with 6. So you can see that the here 4 carbon on the left side, 4 carbon on the right side, and then um, 14 oxygen on the left side, and here also on the right side 14 oxygens are present. So it means this equation become balanced. So basically guys, here what do we need to see, that whenever you burn the carbon and its allotrope into the air, so they will produce carbon dioxide, heat and light. So I hope guys this point is clear to you. If it is clear to you, so let's move on to the next slide. So here on this slide it is written that saturated hydrocarbon will generally give a clean flame, while unsaturated carbon compounds will give a yellow flame with lots of black smoke. So basically when you burn saturated hydrocarbon, so it will burn very smoothly, it will give you a clean flame. But when you burn unsaturated carbon compound, so what will happen, it will produce a black smoke and it will burn with a yellow flame. Okay, so what will happen if this will produce black smoke, so it will result into a sooty deposit on the metal plate. Okay guys, so however limiting the supply of air results in incomplete combustion of even saturated hydrocarbon, giving a sooty flame. So here we got this point that saturated hydrocarbon will generally give a clean flame. Okay, but unsaturated carbon compound will burn with a yellow flame. But still if you limit the supply of air, okay, so if you are not giving the enough supply of air, so the incomplete combustion of the saturated hydrocarbon will also produce a sooty flame. Because when you stop the supply of air, what does it mean? It means that that substance is not burning properly, so it will form a sooty flame. Okay, so you might have seen sometimes that the base of the container becomes black. Okay, so what does it show? It basically shows that the chemical is not burned properly. Okay, or you can say the hydrocarbon is not burning properly, because the limiting the supply of air result in incomplete combustion of even saturated hydrocarbon, and it will give a sooty flame. So I hope guys this point is clear to you. Now the gas kerosene stove used at home has inlets for air, so that a sufficiently oxygen rich mixture is burned to give a clean blue flame. So basically you might have seen the gas or the kerosene stoves at our houses. In olden times these gas stoves are used. So basically in that stove what happened, there used to be a inlet for air. So due to this inlet, what was the purpose of this inlet? Basically, we want that oxygen rich mixture is given to that, you can say, stop, so that it will burn with a clean and blue flame. It means that in the presence of oxygen rich mixture, the chemical will burn properly and it will form a clean blue flame. Okay, so I hope guys this point is clear to you. If the flame is blue, it means that the chemical is burning properly, and if yellow flame is being produced, it means that it is not burning properly. So I hope guys this point is clear to you. So this is very important, that saturated hydrocarbon generally give clean flame, while unsaturated carbon compound gives yellow flame. Okay, but you limit the supply of air, then the even the saturated carbon will give you a sooty flame. So if this point is clear, let's move on to the next slide. Now guys, on this slide, it is written that if you observe the bottom of the cooking vessel getting blackened, so it means that the air holes are blocked and fuel is getting wasted. So on the previous slide, we had discussed that when will the cooking vessel, or you can say the bottom of the cooking vessel, will get black when there is a incomplete combustion of fuel. Okay, then it will produce a sooty flame. Okay, and the bottom of the cooking vessel will get black because it will produce black smoke. Okay, now what does it mean? It basically mean, what is the cause of it? It basically happen because of the lack of oxygen. Okay, it means the air holes are blocked and fuel is getting wasted. It is not getting the enough oxygen rich mixture, so that it is not burning properly. So if the bottom of the cooking vessel getting blackened, so it simply means that the air holes are blocked and fuel is getting wasted. Now, fuels such as coal and petroleum, fuels such as coal, petroleum have some amount of nitrogen. They have some amount of nitrogen and sulfur in them. So their combustion will result in the formation of oxides of sulfur and nitrogen, which are major pollutants in the environment. So basically, it wants to say that some fuels, such as coal and petroleum, they have nitrogen and sulfur as well. Nitrogen and sulfur as well. So basically, what will happen when this nitrogen and sulfur will react with oxygen? So they will form oxides of sulfur and nitrogen, and these are the pollutants for the environment. These are the pollutants in the environment. So I hope guys these points are clear to you. If it is clear to you, let's move on to the next slide. So here on this slide, we will talk about a very important question, that why do substance burn with or without flame? You might have seen that some substances burn with flame, some substances burn without flame. So why is that? Why some substances are forming flame and some are not? So basically guys, a flame is only produced when gaseous substances burn. Okay, it will only produce when gaseous substances burn. So now your question might be that, so we have seen many substances which are not gaseous substances, but they are burning with flame. So here the answer is basically, these substances also have volatile substances. Okay, so what will happen? So when these volatile substances vaporize, so this will burn with a flame. Okay, so here you can see that when wood or charcoal is ignited, the volatile substances present vaporize and burn with a flame in the beginning. So the volatile substances which are present in charcoal or wood, they will vaporize and they will burn with a flame in the beginning. So a luminous flame is seen when the atoms of the gaseous substance are heated and start to glow. Okay, you might have seen that a very luminous flame when atom or of the gaseous substance are heated and start to glow. Okay, in our home we use LPG as a fuel. So when this is burned, so you can see a luminous flame. Okay. Now the color produced by each element is characteristic property of that element. Basically, guys, the color of that flame will depend on the element. What type of element is burning? It will, you can say, it will show the characteristic property of that element. Okay. So I hope guys you might have got the answer that why do some of the substances burn with or without a flame. Okay. So if it is clear to you, let's move on to the next slide. Okay, students. So here we are. Here we will talk about the formation of coal and petroleum. So guys, I think you might have already seen this. Okay, you might have already known about this, that how the coal and petroleum is formed. So basically what happened, these coal and petroleum are have been formed by biomass. Okay, so these are basically the remains of trees, ferns and some of the plants. So what happened, these remains of trees, ferns are crushed into the earth. Okay, at that time they were crushed into the earth, maybe because of the earthquake or some volcanic eruptions. So then they were pressed down by the layers of earth, rock, and then they slowly decayed into coal, and then they converted into the coal. And if I talk about the oil and gases, so basically these are the remains of teeny plants and animals that you can say that lived in the sea. So these are the remains of millions of tiny plants and animals that lived in the sea. So let's see, coal and petroleum have been formed from biomass which has been subjected to various biological and geological processes. So when the remains of trees and farms and some plants have been subjected to various biological and geological processes, so coal and petroleum is formed. So coal is the remains of trees, ferns and other plants that lived millions of years ago. These were crushed into the earth. These were crushed into the earth, perhaps by earthquake or volcanic eruption. They were pressed down by layers of earth and rock. They slowly decayed into coal. So basically, due to the pressure, they converted into the coal. And oil and gas are the remains of millions of tiny plants and animals, so that lived into the sea. So I hope guys this point is clear to you how the coal and petroleum is formed. So if it is clear to you, let's move on to the next slide. When they died, their bodies sank to the sea. Basically it is talking about the oil and gases. So oil and gases are formed, we have seen on the previous slide. They are basically remains of millions of tiny plants and animals that used to live in sea. So when these animals and when these tiny plants died, so their bodies sank into the sea bed and were covered by silt. So basically when these animals and you can say the plants, the small or tiny plants died, so their bodies sank into the sea and their bodies were covered by silt. So bacteria attacked the dead remains, turning them into oil and gas under the high pressure they were being subject to. So now what happened? Bacteria attacked on that dead bodies, dead remains, and then they turned them into the oil and gas under the high pressure, because sea also exert pressure. You might have seen this, that in the previous classes, that let's suppose if it is sea, okay, so basically there is water above it, so this water will exert pressure, and the pressure is the highest on the bottom. If let's suppose this is bottom, okay, and this is top, so pressure will high here on the bottom side, okay, because of the weight of this liquid. So meanwhile, the silt was slowly compressed into rock. Now the silt, okay, which covers the, you can say their bodies, so they slowly compressed into rock. The oil and gas seeped into the porous part of the rock and got trapped like water in a sponge. So basically, this silt which was covering these dead bodies, it is converted into the rock. So these oil and gases seeped into the porous part of the rock and got trapped like a water. So it becomes trapped like a water in the sponge. So I hope guys this point is clear to you. Basically, our motive here is to know that the coal and the gases and the oil, basically these are the remains of trees. These are the remains of you can say bodies, okay, some animals, okay. So I hope these points are clear to you. If it is clear to you, let's move on to the next slide, and let's talk about some other important topics of this chapter. Now guys, on this slide we will be talking about what is oxidation. So basically we know what is oxidation, but specifically we will see oxidation of the carbon compounds, or of the hydrocarbons, okay. So carbon compounds can be easily oxidized on combustion. We have seen this, that carbon compounds were easily getting oxidized. So in addition to this complete oxidation, we have reaction in which alcohols are converted to carboxylic acid. So here guys you can see this is basically an alcohol. This is ethanol, okay, ethanol. So when this ethanol gets oxidized in the presence of alkaline potassium permanganate or acidified K2Cr2O7, okay, this is basically what, this is potassium dichromate. So in the presence of these two, when this ethanol gets oxidized, so it will form this carboxylic acid, okay, this is what, this is ethanoic acid. So you can see that it gets oxidized in the presence of these substances, alkaline KMnO4 or acidified K2Cr2O7, which is alkaline potassium permanganate, and this is basically K2Cr2O7 is what, this is potassium dichromate. So some substances are capable of adding oxygen to other. These substances are capable enough to add oxygen in these substances. So these substances are known as oxidizing agent. This is very important. This is what, this is oxidizing agent. We have seen this in the previous chapters. Then what is an oxidizing agent? Which are capable of adding oxygen to the other. These are known as oxidizing agent. So alkaline potassium permanganate or acidified potassium dichromate are oxidizing alcohols to acid. So this is what basically these are basically working, acting as an oxidizing agent, because they are adding oxygen to this ethanol and turning it into ethanoic acid. So these are the oxidizing agent or oxidizing, these are oxidizing alcohols to acid, okay. You can see this is alcohol and this is acid. So alcohol has been oxidized in acids. So adding oxygen to the starting material, you can see that it is adding oxygen into this, and hence they are known as oxidizing agent. So that's why these two are the example of oxidizing agent. And why is the example of the oxidizing agent? Because you can see that they are adding oxygen to the to a substance and making it, or you can say turning it into the acid. Alcohol is turned into acid. So if these points are clear to you, let's move on to the next slide. Okay students, so here we are. So guys, here we will talk about what is an addition reaction. Okay, so basically here it is written that unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give saturated hydrocarbons. So let's suppose this is CH2 double bond CH2. This is what this is ethane. So this is basically unsaturated because you can see here is a double bond between these two carbon atoms. Now if it becomes CH3 CH3. So you can see I have added one hydrogen to both the carbon. Now it becomes saturated. Okay. So basically guys, what happens? These catalysts are the substance which are, you can say, which add hydrogen to the unsaturated compounds and convert it into the saturated compound. So you can see that such as palladium and nickel is a very great example of these type of you can say catalyst, because catalysts are adding hydrogen so to give saturated hydrocarbon. Now catalysts are the substance that cause a reaction to occur or proceed at different rate without the reaction itself being affected. So basically, these catalysts do not participate in the reaction. They just change the rate of the reaction. Okay. So you can see on the in the presence of this nickel, hydrogen is added to this. Okay. So this reaction is commonly used in the hydrogenation of vegetable oil using a nickel catalyst. So basically this is the reaction which is used in the hydrogenation of vegetable oils. Vegetable oil are unsaturated, and when you add hydrogen in it, they will become saturated, and this happen in the presence of nickel catalyst. So vegetable oil generally have long unsaturated carbon chains. It is written here that vegetables oils generally have long unsaturated chains. They have unsaturated carbon chains. So while animal fats have saturated carbon chains, but animal fats have saturated carbon chains. So I hope guys this point is clear to you. What is addition reaction? You can see hydrogen is added to this unsaturated compound, unsaturated hydrocarbon. Now let's move on to the next slide and let's talk about the other important points. So here at this slide we will talk about the substitution reaction. So guys, basically generally the saturated hydrocarbon do not react, because you can see that this is CH4, this is methane, so it will not react easily. But guys, what will happen in the presence of the sunlight? Chlorine is added to this hydrocarbon. Okay, the chlorine will add to this hydrocarbon. So what will happen? One chlorine will remove this hydrogen and it will take its place. So this is now basically CH3Cl. Okay, and HCl is produced. Okay, because one H which is removed from this methane and one Cl will react and they will form HCl. So chlorine can replace the hydrogen atom one by one. It is called a substitution reaction. Now what will happen? This chlorine will again remove one hydrogen and it will take its place. Then it will again remove one hydrogen and take its place. So basically this will happen in the presence of sunlight. So it is written here that saturated hydrocarbon are fairly unreactive and are inert in the presence of most reagent. It means it doesn't react easily. But however, in the presence of sunlight, chlorine is added to hydrocarbon in a very fast reaction. Chlorine will be added into this hydrocarbon. So chlorine can replace the hydrogen atom one by one. So it will replace all the hydrogen atom one by one. Okay, so it is called a substitution reaction. So basically atoms are removed in this reaction, so that's why this is known as substitution reaction. So because one type of atom or group of atom takes the place of another, you can see that chlorine is taking place of hydrogen. So one type of atom is taking place of the other atom and removing it from its compound. So a number of products are usually formed with the higher homologous alkanes. So what will happen? So higher homologous alkanes will form, you can say, number of products. Okay, so I hope guys this is all about substitution reaction and this is clear to you. If it is clear to you, let's move on to the next slide and let's talk about some of the examples. So this is example number first. Why is the conversion of ethanol to ethanoic acid an oxidation reaction? So first of all, we will see that C2H5OH, this is what? This is ethanol. Now, when this is converted into the ethanoic acid, so basically this is what? CH3COOH. Okay, and this conversion will take place in the presence of potassium permanganate, okay, or potassium dichromate. So guys, you can see that here only one oxygen is present, here two oxygen atoms are present. So because oxygen is added, so that's why this is an example of oxidation reaction. Now let's talk about this second question. A mixture of oxygen and ethane is burnt for welding. Can you tell why a mixture of ethane and air is not used? So basically, so guys, on the previous slide we had discussed, then when substances are burnt with oxygen, so in the presence of enough oxygen, or you can say high oxygen, they will burn with a clean flame, or you can say they will burn completely. But if it will burn in the lack of oxygen, then it will not burn completely and they will form a sooty flame. So that's why ethane is burned with oxygen, so that it will burn completely. Okay, and it you can say it is used in welding. But this is not possible with the air. Okay, this much temperature which comes burning of ethane with oxygen will not come burning of ethane with air. So I hope guys these 2 points are clear to you. If it is clear to you, so thank you so much guys. Now I am ending this lecture and we will meet in the upcoming lecture. So see you later.